The crankshaft is 3/16 rod that was included, so I need to drill and ream a 3/16 hole into the main casting here. So that's what I'm going to do next, and as mentioned previously, this is going to be trimmed. I'm not sure where, here and someplace over here. Boy, that casting is pretty rough right there. But this is the spigot, or stem as I call it. They call it a spigot, that can be used to hold in the 3-jaw chuck in order to drill and ream, and that's a handy thing to have because remember that I want this hole to be perfectly parallel with this hole and on the same plane vertically from the base up. So how am I going to do that? Well, I already took it over to the Atlas lathe and held it, and I turned the machine on, and just as I figured, it was way out of balance and it shimmied like my sister Kate. So I'm going to use the closing lathe. Wow, that little casting is dwarfed by this big chuck, isn't it? But that gives it the mass so it doesn't vibrate. Watch and you'll see what I mean. Now I've already faced it off, and by looking at the face marks I can see that the center really does appear to be in the center of the I'm going to call this a boss. So I'm ready to center drill and then 11/64 and then 3/16 ream. I like to lay my tools out and double check the sizes on them because you only have one shot at this. Also, this does not need to be drilled clear through all the way through that little stem or spigot. So I have marked this drill bit with a green Sharpie, and that's how deep I'm going to go, and even that's probably deeper than what I need. Are we having fun yet? Now, before you start cutting, get your glasses on by the way, always turn your chuck over by hand to make sure that it's going to clear when we have something that is irregular as this. So it's going to clear the compound. Get that back out of the way. Also, I'm running the lathe much slower than what is necessary, but also to minimize vibration. And again, no lubrication needed with this cast iron, but boy is it messy. And now the reamer. There's a lot of guesswork as far as the location of things and dimensions on this because it isn't a full-blown working drawing, but since I've done things like this before, it isn't really so hard for me. But right now I need to determine where I'm going to cut this off. This is all scrap waste stock right here, but I believe the stem ends, the spigot ends right about here. You can see there's two different diameters. So that's where I'm going to cut it off, but probably need to trim it again later on, and this will be trimmed, and that's no big deal. But looking at it like this, I want to make sure that it's long enough, although I can shim it with washers, but We got the thickness of this to deal with, and you can see the approximate location here so that the rod coming off the crank here comes to the center of the cylinder. But anyway, I'm going to cut it, and just with a hand hacksaw, I'll hold this in a vise and saw it off, and that should expose the hole. And this is the inaugural run for this beautiful high-tension Lennox hacksaw that Paul sent me, along with a brand new Lennox blade. Cuts like magic. And there's the hole, and I'm pleased to say that it appears to be in the center of the casting. I was a little worried about it coming off center. You just never know what's going to happen. So the stem, which is sitting right here, was quite accurate in holding the work. And your hands will quickly turn black handling cast iron swarf. At a later time, I'll put this back in the milling machine and using the end mill, square that off when I determine what the length will be. That'll give me a square end on it. I can do the same thing down here. And that's the crankshaft, 3/16. Later on, I'll also be putting an oil hole right here. And a hole that is just countersunk would be really quite sufficient, but I may make a little brass oiler, I don't know, just an oil cup. Okay, just for a change of pace now, I'm going to go and change my direction here and work on the flywheel. But there's quite a bit more work to do on this, namely the hole drilled through here, and then the ports for the steam, both the pressure and the exhaust. Other than that, this is coming along quite nicely and very enjoyable. There's no dimensions for this, and the whole idea is to just clean it up, and we want it to be as thick and as wide, or I do, as possible for the mass. The whole purpose of a flywheel is for the mass. So I'm going to start by taking it off camera to the belt sander and cleaning up the periphery. That's the gate. But there's just a little bit of a line here where the parting line was, parting plane. Very little need for filing in here, but I may do some of that off camera. Some people like to spend a lot of time cleaning and polishing. I don't do a whole lot of that. But the thing here is I want to drill and ream a 3/16 hole. There will eventually be a set screw hole to hold this to the shaft, and turning the periphery and the two faces. Stuart provided a spigot or a stem on here, the purpose of which I believe is to hold it while turning, but notice it's a reduced diameter, so it'll lack a little rigidity because of that. But putting this in the 3-jaw chuck, now let's see how true it runs. Just snug it a little bit. And you can see it's got a wobble to it, so it's not running very true. So let me try, and the idea is I would like to hold it so that I am able to do most of the operations in one setup. That is, that would allow me to face this, drill and ream, face this surface here, and turn it to diameter so that everything would be concentric and true, and then I would have to flip it around to do the backside, which is no big deal. But I have an idea here. Well, for one thing, I can reverse the jaws, probably on a smaller lathe than this, and hold it by the outside. But again, that doesn't allow you to turn that surface, so I'm rejecting that method. But let me see if I can hold it with this hub. I'm going to call that the hub. well, I'll call it the hub because it is the hub, I guess. And I'm able to push this up against the true surfaces here of the chuck jaws. Remember that a casting is somewhat irregular and imperfect. Let's see what we got now. That runs pretty true. I like that setup, so that's how I'm going to hold it. So I'll start by sawing off the stem here, off camera, and then I'm going to drill it and ream it the same as what I did on the previous casting. I may not show all of that. I've already sawed off the stem with that nice Lennox hacksaw, and I'm ready to face the hub. And now the pilot drill all the way through. And now the reamer all the way through. I really like this big gator chuck that was donated to me, but in reviewing the footage I could see that I wasn't quite as perfect as I thought. But remember, the castings are irregular, so there is some wobbling, but I'm going to true that all up on the three surfaces that are concerned, but there may still be a little wobble on the hub or the inner part here, but that is not going to hurt anything. So now I'm ready to face. See if that trued it up. I think I'll put a little marking on there and then take a final pass and see if it all cleans up. Looks just fine. I may touch it up with a little emery cloth, but then again, I may not. I'm using my carbide tool here. It's a Schar's. I'm using both ends, as you can see. I'm turning at about 650 RPM, and it's a 6,000ths feed. I always get people that ask me some of those questions, so I thought I'd throw that in. Oh boy, does that cast iron turn nice. Let's see if it cleaned up. And it did. It's cleaned up all the way around. I'll chamfer that corner a little bit. took the flywheel out and I was going to reverse it like this to machine the other side, but so little is held in this short hub here that it wouldn't be safe. So I'm going to switch lathes, and I'm going over to the Atlas lathe using this chuck with the reverse jaws, and it'll be held something like this. Then I'll face off this hub to length and face the surface that I'm touching with my forefinger. Now I'm at the Atlas lathe with that chuck with the reverse jaws. I notice that I have little pieces of foil wrapped around, heavy-duty foil, that's not kitchen foil, could be copper or anything, to possibly protect the finish on this, but you know, that's up to you. And I'm going to face the hub off first to that white chalk line, and I'm leaving that a little bit longer than what I would normally do because that's the area where I want to drill and tap a hole for the set screw, and by doing that I can drill the hole perpendicular to the hole rather than at an angle, which is always troublesome when there isn't much of a hub. And next I'll face it. Again, there's no dimensions, just until it's cleaned up, and I put some marker on there. Now I'll break that corner with a file and polish ever so lightly, and this is done except for the set screw hole. In a recent video by John Saunders, he was doing some cast iron on his CNC machines, and he talked about what a mess it was to clean up, and cast iron's always a mess. And he said that they even need to allow time, you know, in the job, perhaps 2 hours I think it took to clean that up, and need to charge for that. But he said he had thought about using magnets in a baggie. Now he's working with much larger machines, but I did just that, and I caught some, but I see that a lot of the chips ended up right there, so I would need a lot more magnets with a lot more surface area to make that successful. Just thought I'd throw that in. I have a confession to make. I already lost the tiny set screw that I assume was to be used on the flywheel. How I could have lost it, I don't know, because I got a magnet here. Also, there's one brass screw missing, and I'm wondering if there were 4 brass screws to start with. I'll have to go back and look at the earlier footage. But anyway, the set screw that they provided to me was way too small. It was the diameter of this 7BA. It probably was a 7BA, and to me it's not up to the task of holding this onto a shaft. So I'm upgrading here to a 632 set screw, and I'm going to, as I told you here a few moments ago, drill and tap a hole into this hub. And that's why I have an extra long hub here, and it'll be held like that. Sometimes I had to use a tilting vise and drill it at an angle. You can visualize that I would have to, on this side, the set screw would have to come in at an angle, which also means that the set screw is only touching the shaft on one corner. So that's why I'm making a big deal over this. That's what I'll do. Here in Illinois, and it's March of 2017, we have a plague of these tiny little bugs, beetles. They're not ladybugs. They were an introduced bug, I think, to help with the soybeans or something like that. But it was a mistake. And they're just terrible in the fall. They get into the house. And here it is March, and I'm still finding them around here. And this one just landed in my hair. I vacuum them up. The problem with them is they stink so bad. And there seems to be no solution to exterminating them. Boy, that was off topic. It's shaping up. Of course, this is way too long, so the shaft isn't sticking out. Matter of fact, I'll probably have to make another shaft. But the possibility here is also that I should use 2 set screws at right angles to one another. And some people in their small projects like this actually use a tiny keyway, but I don't have any broaches that small. But it runs true, and that's the main thing I was worried about. Now, some other people like to turn their flywheels on an arbor. However, with a small diameter hole like this, probably it's going to slip on you, and the set screw is going to tear up the shaft and all of that. But I used to try to turn them on an arbor, so if you're holding them in a collet, you really get a nice true cut. But that's the way I do it. There are many different ways of turning a flywheel. That's my turn on it. All right, on to the next step. I just did a little milling off camera. I milled this down to the right length and took some off of this. I might need more. And I milled a flat on this boss because that's where I want to do the layout. But looking at it now, when I put it back on the base and line up the holes here, just roughly, you can see that I've got the right spacing down in here where my finger is. Again, there's no dimension for that. Now, one thing I thought of, and I just want to point out, is that I'm going to paint this later on. So if I already had the paint and knew the color and everything, it would have been so nice to have painted this first and then done the machining, because then there'd be no masking to do. Other than a little filing, if I decide to do it, this is done. Well, I've been at this for about 6 hours. That's enough for today. I'll see you on the morrow.